Supply chain under siege. The supply chain worm known as Shai-Hulud, named, with apparent literary flair after the sandworms of Dune, has burrowed deeper. Socket Security confirmed that newly compromised packages now include at OpenSearch project/OpenSearch versions 3, 5.3 through 3, 8.0, pulling 1.3 million weekly downloads, mistralai 2, 4.6 on PyPI and guardrails-ai 0, 10.1 on PyPI. The guardrails-ai package executes malicious code on import, downloading a payload from git-tanstack.com and running it without integrity verification. The attackers left a calling card. The domain displayed a message signed "With Love Team PCP," alongside a boast about stealing credentials for over 2 hours. Meanwhile, model repositories are getting the same treatment as package registries. A fake model called OpenOSS/privacy filter appeared on Hugging Face, presenting itself as an OpenAI privacy filter. It is actually a Python-based dropper that downloads a malicious PowerShell command, which spawns another PowerShell instance, which downloads a Rust-compiled infostealer targeting Chrome credentials, WinCP sessions, and more. The chain is loader.py to base 64 encoded URL to PowerShell batch file, to yet another base 64 PowerShell script to the final compiled binary. Layers of obfuscation that would be comical if the package hadn't accumulated 244,000 downloads before being reported. The accounts liking the model show patterns consistent with coordinated bot activity, some already closed for violations yet still boosting new malware. At press time, the repo remained live. The absurdity of modern supply chain security is best captured by a satirical incident report making the rounds. CVE2024. YIKES chronicles a fictional cascade where a compromised NPM dependency leads to credential theft, which enables a supply chain attack on a Rust compression library, which gets vendored into a Python build tool, which ships malware to approximately 4 million developers, before being inadvertently patched by an unrelated cryptocurrency mining worm. Every individual failure mode is real. Hardware 2 FA keys going missing, Google AI overviews linking to phishing sites, Dependabot auto-merging malicious PRs, because CI passes after the malware installs the test runner. Total machines saved by a cryptocurrency worm, also estimated 4.2 million. Net security posture change, uncomfortable. On the defense side, Root Evidence's Robert Hansen proposes a provocative strategy. Use AI to rewrite third-party libraries entirely, eliminating CVEs by removing the vulnerable code from your codebase. The tool, Lib-Theseus after the ship of Theseus paradox, is a Claude Code Codex skill that identifies dependencies, studies their actual usage, generates tests, writes replacement code, and cleans up artifacts. In testing, it rewrote 14 of 18 modules 78%, with only platform-critical packages like Electron left untouched. The upsides are clear. No vulnerable library means no CVE, no future supply chain compromise, and potentially fewer licensing headaches. The downsides are equally real. NPM audit cannot find vulnerabilities it does not know exist, and AI-generated replacements could introduce novel bugs. Europe's digital security reckoning. The Internet Cleanup Foundation launched securitybaseline.eu, a transparency platform auditing the cybersecurity posture of European government websites across 32 countries, 67,000 local governments, and roughly 200,000 domains. The project expands the Dutch Basis Beveiliging initiative, which has been measuring government website security for over a decade, to the entire EU and EEA. 3 months before launch, the foundation sent tens of thousands of advance notification emails to affected governments. The results suggest those emails were largely ignored. 3 findings stand out. First, 3081 government websites place tracking cookies on visitors without consent, a straightforward GDPR violation. YouTube embeds are the primary offender at 2,077 tracking cookies, followed by Google Ads at 842, Facebook at 293, and TikTok at 20. Slovakia leads at nearly 10% of government sites, followed by Greece at 8% and Portugal at 7.6%. The foundation notes these are mostly side effects of embedding modern web components without understanding the surveillance implications. Second, over 1,070 FP-Madmin database administration portals are publicly reachable across EU government domains. France leads with 513 exposed instances, Poland with 499, Hungary with 368. 2 of these panels sit at CSRT addresses, the organizations theoretically responsible for preventing exactly this kind of exposure. The foundation found 0 financial contributions from any EU government to the FP-Madmin open source project, despite widespread dependency on it. Third, 99% of European governmental email fails current encryption best practices. Only the Netherlands' 58% compliance and Denmark 44% show promising numbers. There are no EU-level TLS standards for government email, and the country-specific guidelines that do exist are incompatible. The platform rebuilds its 1,827 maps nightly across 21 metrics, coloring each region traffic light style. Right now, the continent is overwhelmingly red. Agent orchestration grows up. The gap between agents that work and agents you would trust in production is where the interesting engineering happens. A research paper from Huawei Noah's Ark Lab in UCL pushes multi-agent coordination into genuinely novel territory by modeling it as organizational design. OneManCompany OMC separates a portable talent, identity role, skills, working principles from a runtime container line graph, Claude code, or script-based, connected through 6 typed interfaces that mirror an OS kernel: process management, memory, file system, I/O, IPC, and security. A community-driven talent market provides on-demand recruitment through 3 channels: curated open-source agents, prompt source personas assembled with matched skills, and dynamically assembled agents from cloud skill libraries. The most provocative element is OMC's HR pipeline. Agents undergo one-on-one feedback after each task, participate in project retrospectives that produce updated SOPs, and face formal performance reviews every 3 projects. Fail 3 consecutive reviews, and you enter a performance improvement plan. Fail 1 more, and it is automated offboarding. The container is deprovisioned, and the capability gap is flagged for re-recruitment. On PRD Bench 50 project-level software tasks, OMC achieved 84.67% success rate, a 15 percentage point improvement over prior state-of-the-art at about $6.91 per task. Cross-domain case studies ranged from $1.57 for audiobook production to $16.26 for an automated academic research survey. GammaLab's Harmonist takes a complementary approach. Instead of organizational metaphors, it enforces protocol compliance mechanically. Every code-changing turn runs through IDE hooks that verify required reviewers executed, memory was updated, and protocol was satisfied, returning a structured follow-up message if anything is missing. The LLM literally cannot ship code that skipped review. Supply chain integrity is baked in via SHA-256 manifest for every file, with the upgrade process verifying hashes before copying and refusing tampered agent definitions outright. A prompt injection scanner checks agent markdown for override attempts, exfiltration patterns, and policy subversion. All running on pure Python, steadlib, and bash, 0 external dependencies. On the practical deployment side, the community consensus around OpenAI's codex-at-scale approach was telling. The most reliable safety mechanism isn't prompt-level constraints. It's tool scope. An agent that can only write to specific directories and run specific commands fails safely when it tries to exceed scope. Hard boundaries beat soft instructions every time. Deep Swarm offers a narrower but practical tool. Task-agnostic parallel API worker orchestration with tiered model delegation, frontier model plans, cheaper model executes, auto-optimized worker counts, and 99.95% API success rates across 31,000 calls. Daniel Miessler's PAI project. Described as an OS on top of Claude code with 12,000 GitHub stars. Ripped out RAG entirely in favor of plain text files navigated with ripgrep, reasoning that with sufficient context windows, search becomes navigation. It's 3-tier memory hierarchy work, knowledge, learning compounds across sessions while the system itself deliberately shrinks as models improve. What the developers call bitter-pilled engineering. Model architecture. From Monolith to Modular, mixture of experts models have been pitched as a way to get big model performance at small model cost, but in practice, removing experts kills performance because routing learns low-level lexical patterns rather than semantic domains. Allen AI's EMO emergent modularity fixes this with a deceptively simple change. During pre-training, all tokens in a document must choose active experts from a shared pool. This single constraint causes expert groups to naturally specialize by domain: code, law, biomedical, web content, instead of clustering around prepositions and punctuation. The numbers are striking. EMO uses 1 billion active parameters from 14 billion total 8 of 128 experts per token, trained on 1 trillion tokens. At 12.5% of experts retained, performance drops only about 3%. A standard MOE at the same subset size degrades to near random. At 25%, the drop is roughly 1%. Expert selection is remarkably cheap. A single few-shot example suffices to identify a good subset for any domain. Global load balancing across documents rather than within a microbatch proved essential for training stability, and the pool size is randomly sampled during training rather than fixed. The practical implication is significant. Deploy only the expert subset needed for a specific task, achieving memory accuracy trade-offs standard MOAs cannot offer. Model, baseline, and training code are all open. If EMO rethinks model structure, Thinking Machines Lab rethinks model interaction entirely. Their interaction models, research preview replaces turn-based exchanges with continuous 200 millisecond microturns that interleave input processing and output generation across audio, video, and text simultaneously. There are no artificial turn boundaries. The model tracks implicit turn states, interjects proactively, translates live, and executes concurrent tool calls while conversing. The architecture pairs a real-time interaction model 276B MOE, 12B active, with an asynchronous background model for deep reasoning, achieving state-of-the-art combined performance on both intelligence and interactivity benchmarks. Existing models, including GPT Real-Time 2, cannot meaningfully perform the visual proactivity tasks the team introduces, such as counting exercise repetitions or responding to visual cues without being prompted. Local AI performance wars. A single command line flag is saving people thousands of dollars. A llama.cpp user discovered that increasing the microbatch size UB dramatically improves prompt processing for partially offloaded Mo models. On an RTX 3090 running GPTOS 120B, pushing UB from the default 512 to 8192 boosted prefill throughput from 380 TOC/S to 2090 TOC/S, a 5.5x improvement, while token generation dropped only 7%. The trade-off: larger batches need more GPU workspace, requiring a few extra MOE layers on the CPU via NC-PUMO. Bigger batches mean fewer kernel launches, keeping the GPU saturated during prefill, while generation speed barely changes because it is memory bandwidth bound on CPU expert weights. One of the reasons I bought a DGX Spark was better prompt processing. If I had known about this trick, I might not have. Speculative decoding is pushing consumer GPUs into territory that previously demanded multi-card setups. Gemma 426B MOE with 4 billion active parameters hit 578 output tokens per second on a single RTX 5090 using DF-Flash speculative decoding in VelLM. A 2.56x speedup over the 228 TOC/S baseline. The optimal setting was 13 speculative tokens with max batch tokens of 8,192. Interestingly, the lowest mean latency configuration was not the best serving configuration due to worse P95 tail latency. Community pushback noted DF-Flash performance degrades above 20K context, and that random dataset benchmarks overstate acceptance rates versus real workloads. But for short context inference, the throughput is undeniable. AMD's viability as a full training platform gets a concrete data point with ZAYA1. 8B, a frontier MOE model pre-trained entirely on 1024 AMD M.I3. 00X nodes with Pensando Polara interconnect. The architecture introduces Markovian RSA, a novel reinforcement learning technique, and uses 0.8 billion active parameters from 8 billion total. Whether it beats Qwen 3.59b is debatable, but the training stack proof of concept matters. The hardest part is always the first run for a new lab. And given that they're running on an AMD stack, they had an even bigger hill to climb. On the tooling front, Jerganov merged Llama eval directly into llama.cpp, providing standardized evaluation against AIME 20, 25GSM8K and GPQA without the API key or transformers dependency that plagues most benchmarking setups. Saves everyone from setting up their own janky benchmark pipeline that measures different things. And at the opposite extreme, someone got Carpathy's Tiny Stories 260K running on a stock Game Boy Color. ENT8 weights, fixed point math, bank switched cartridge ROM, KV cache and SRAM. It is extremely slow and the output is gibberish, but transformer prefill and autoregressive generation genuinely execute on 1998 hardware with 32 KB of work RAM. As one commenter put it, pointless, therefore indispensable. Intent, evaluation, and the personality problem. A new benchmark called Intent Grasp puts numbers on something practitioners have long suspected. AI models are substantially worse at understanding what users actually want than at generating fluent responses. Across 20 models from 7 families, all scored below 60% on the full benchmark and below 25% on the harder GEM set. The paper distinguishes declared intent what someone types from enacted intent what someone does, arguing that as agents turn language into action, misinterpretation does not produce a wrong answer. It produces a correctly executed wrong goal. The good news: intentional fine-tuning substantially improves performance, meaning intent comprehension is trainable, not a fixed ceiling. The commercial implications are clear. Organizations wanting agents to handle more valuable work need better intent interpretation before they widen authority. Clarification loops, context grounding, task boundaries, escalation points, and stop conditions. The evaluation problem runs deeper than intent. A candid post on r/learn machine learning confesses what many teams will not. Most of what I've been calling evals has been vibe checks. The author nearly shipped haiku over sonnet based on testing 6 prompts, only to find in a proper held-out evaluation that Sonnet was winning by a meaningful margin on the cases that mattered most. A real eval requires a held-out dataset, a scoring rubric, and a comparison table. When an engineer asks, "Why are we picking this? You have numbers, not vibes." The community response confirmed how endemic the problem is. 6 prompts and a gut feeling being called evals is way more common than people want to admit. Claude specifically is developing what users describe as radical over-honesty mixed with absolute certainty about timelines it doesn't understand, confidently estimating months of team effort for things already running in another terminal. The training data still assumes software is built through committees and sprint planning. Meanwhile, practitioners are shipping entire frameworks between breakfast and dinner. The irony, the same model lecturing about ambition is often fully capable of building the thing if you ignore the lecture and keep prompting. The practical remedy, according to Ofer Meir, is structured team-wide AI literacy, weekly show-and-tell sessions, where people demonstrate what they have built, pushing everyone past the event horizon of AI savviness, where it becomes hard not to be a fanatic. On the infrastructure side, Faultline tackles LLM memory reliability by building a searchable knowledge graph from conversations with explicit validation gates. Facts are validated against existing knowledge, stored in a user-controlled database, and injected as grounding context before the model responds. Short-term vector search handles recent context while long-term relational storage locks invalidated facts across sessions. The project draws on several open research problems. Right gates, fact lifecycle management, self-building ontologies, that remain unshipped in production systems, making it an early test of whether academic memory governance concepts actually work outside the lab.